Hello everybody, I hope you are well. Today I want to talk about the reaction yield, but first I will solve the practice that we had from last session. The reaction between benzoic acid and octanol to yield octyl benzoate and water is carried out with an excess of octanol to help drive the reaction to completion and maximize the yield of product. It's sometimes possible that that chemists in laboratory use excess of one reagent apart from the molar ratios on the balanced equation to be sure that they can complete this reaction and get the maximum amount of the product. If an organic chemist wants to use 1.5 molar equivalents of octanol, how many grams of octanol would be required to carry out the reaction with 50.7 grams of benzoic acid? Okay, to solve this practice, first I will write benzoic acid. I will define another name for that, and octanol like here to simplify them instead of writing the whole formula. X gram of octanol, we have to find it when there is 50.7 gram of benzoic acid. Have to convert the units. 1 mole of benzoic acid, it has a molar mass of 80 grams of benzoic acid. Using the mole ratios, 1 mole benzoic acid, and we have to write 1.5 mole of octanol because the chemist has used the excess amount of octanol. And 1 mole octanol has the molar mass of 130.224 grams of octanol. Similar units go with each other, and the final result is 25.1 gram of octanol. Reaction yield, what's that? The amount of limiting reagent present at the start of the reaction determines the theoretical yield of the reaction. If we want to do a comparison between theoretical yield and then actual yield, I will tell you. Theoretical yield is the expected yield, and it's the amount calculated from the balance equation, which is always greater than actual yield, while in the actual yield is experimental yield that we get in the laboratory. This amount obtained in a chemical reaction, and it's always less than theoretical yield. Actual yield is almost always less than the theoretical yield. There are many reasons for the difference between actual and theoretical yields. What are the reasons? For example, many reactions are reversible, and so they don't proceed 100% from left to right. It may be difficult to recover all the product from the reaction medium, and the products formed may react further among themselves or with the reactants to form still other products. Let's solve a practice together. First, before solving the practice, I want to tell you that to determine how efficient a given reaction is, chemists often figure the percent yield, which describes the proportion of the actual yield to the theoretical yield. It is calculated as follows. Okay, so this is the formula that how we can find the percent yield. First, we should have the actual yield getting from the laboratory. We can calculate the theoretical yield from the limiting reagent, and then by dividing these two amounts, we can find the percent yield. In this practice, we can see how the percent yield can be obtained. Titanium is prepared by the reaction of titanium chloride with molten magnesium between these two temperatures. In a certain industrial operation, a specific amount of titanium chloride is reacted with a specific amount of magnesium. So we have the amounts of the starting materials in this reaction, and we can calculate the theoretical yield of titanium in grams. The theoretical yield of titanium is dependent to the limiting reagent. So first we have to find the limiting reagent, and then we can find the theoretical yield. So I will calculate the mole of titanium as a product. How much mole of titanium, while we want to use the titanium chloride as a starting material. So 3.54 multiply 10 gram of 10 to 7 gram of titanium chloride. Unit conversion, 1 mole titanium chloride, 189.7 gram of titanium chloride. So based on the equation, we know 1 mole titanium chloride equals to 1 mole titanium. And the result is 1.87 multiplied by 10 to 5 mole titanium. The amount of titanium while we want to use magnesium, 1.13 multiplied by 10 to 7 gram of magnesium. Unit conversion, 1 mole magnesium, while we have 31 gram of magnesium as a molar mass, multiply by we know that based on the balanced equation, each 2 mole magnesium equals to 1 mole titanium, and the final result is 2.32 multiplied by 10 to 5 mole. Since the amount of produced titanium starting from magnesium is higher than titanium chloride, so titanium chloride is considered as the limiting reagent which can produce less titanium, and the limiting reagent is that reagent that can lead to the theoretical yield. So for calculation of the theoretical yield, I have to use the produced titanium starting from titanium chloride. I have to convert the unit from mole to grams to find the theoretical yield of titanium. So I have to write X gram of titanium, while I have 1.87 multiply 10 to 5 mole of titanium. and we know 1 mole titanium, it has the molar mass of 4788 gram of titanium. The result is 8.95 multiplied 10 to 6 gram of titanium. That is the theoretical yield, and we need to use it to find the percent yield. Okay, we had them. Calculate the percent yield if this amount of the titanium are actually obtained using the formula. Percent yield, I told you, which is the actual yield that is given in the practice, 7.91 multiplied into 6 divided by theoretical yield. Theoretical yield is the amount that we have found from the calculations, 10 to 6. Multiply, the units are in gram, multiply by 100, which has the result of 88.4%. That is the percent yield. In the next lessons, I will start a new chapter, reactions in aqueous solutions, containing precipitation reactions, acid-base and redox reactions. Follow me for more lessons. See you soon.